Hello viewers, my name is Mr. Moses Kutuza from East London Science College here in Buffalo City Metro District. Welcome to the Eastern Cape Department of Education broadcast studio. Today's lesson is about maps and plans. I will be covering three subtopics, that is scale, maps and plans. Welcome to the maps and plans, which is a topic in our paper 2. Remember, paper 2 has got measurement, maps and plans, then probability. So today's lesson, we are focusing on maps and plans. Remember, maps and plans and other physical representations, it contributes around plus or minus 60 marks in your paper 2. So it's equally an important area which is easier to score more marks. Okay, let's start off with the definitions. In the first term I want to look at is scale. Scale determines how many times smaller an object shown on a plan or map is that of its actual size. In other words, we are saying a scale is used to reduce the size of an object so that it can fit on the paper. Remember, look at how big this country is, South Africa. But if we want to make it fit on a paper, we are going to reduce its size by a scale. We will look at the type of scale later on in the lesson. The other term which is important is map. Map is a symbolic representation of selected characteristics of a place on a flat surface. So map represents the top view of the Earth surface. All these terms, you can check them in the document you received from your educators on terminology. The other term which is important is floor plan. Floor plan shows the design and dimension of the inside of a building from a top view. You will see other books talk of from as the view from above or a bird's eye view. So the key word here when you are explaining floor plan is the top view or the view from above. Then elevation plan shows the design and dimensions of outside of the building from a side view. So you can see that the floor plan and the elevation plan, how different are they? But they are both plans, but they are different. The elevation plan shows the side view. Let me move straight away to the types of scale. We have two types of scale basically we use in mathematical literacy. That is the number scale, which is also known as the numerical scale or numeric scale, which is in ratio form, e.g. 1:100. The number on your left represents the measurement on the map, and the number on the right represents the actual measurement. So what does this mean? This means 1 unit on the map or the plan represents 100 units in reality. Remember, the number on the left represents measurement on the map, and the number on the right represents measurement on the reality or on the actual object. Number 2 scale is the bar scale. The bar scale is also known as the line scale. This is the most appropriate on a map because it remains relevant even when the size of the map changes. Let's take, for example, when you are photocopying the map, it shrinks and the size of the map reduces. That means the bar will also reduce in correspondence to the map, whereas the number scale does not do that. So the number scale becomes irrelevant if the map size changes. And you will find that the bar scale is mostly used only on maps, and the number scale is used on both maps and plans. I've shown you if you look at the slide here, two different types of the bar scale. So this is showing the relationship between distance and the map. So in other words, what are we using it for? If we measure distance between two places on the map, we come also and measure the length of our bar. In this case, if we're to measure this length of the bar, let's say it comes out to be 1, 2, 3, 4, 5, 6, 7, 8 centimeters. Then it means 8 centimeters on this bar represent 300 kilometers in reality. Therefore, now if you go to the map, you measure on the map. For example, let's say we measure on the map and we get 5 centimeters. How do we calculate the actual distance now? Then we need to say 5 divided by 8 times 300. 5 divided by 8 times 300. So it will be 5 divided by 8 times 300. That means the kilometers between that place, which is 5 centimeters apart on the map, will be 187.5 kilometers. So that's a bar scale. We use it mainly for maps. 3 things that can be asked in the exam. Number 1, you can be asked to find the real life measurement. That is where you calculate the actual distance between 2 places on a map, like what I was showing there. If the scale is 1s to 500,000 and the map measurement is 3 centimeters, how do we calculate the actual? Remember, we said 1 is the map, represent the map, the left side, and 500,000 is the actual. So I will take the map measurement times the actual, which is 500. 3 times 500,000, that gives me 1,500,000 centimeters. But you can't give someone distance in centimeters. You need to change it to kilometers. So we are going to convert. I've put there, remember, 1 kilometer is 100,000 centimeters. So converting from a smaller unit to a bigger unit, you divide. Hence, we are going to take 1,500,000 and divide it by 100,000 to get 15 kilometers. So we are saying this place, which is 3 centimeters on the map, when we put it in reality, it becomes 15 kilometers. Thank you. Let's go to number 2. You can be asked to find the map measurement. You can be asked to find the map measurement. Thereby, you will be given the actual distance and the scale. The example here is the actual distance between 2 places is 60 kilometers, like maybe the distance from East London to King Williamstown is 60 kilometers. Calculate the distance on the map if the scale is 1s to 1 million. So you do in proportion form like that. Remember, the 60 kilometers is actual kilometers. So we put it on the side of the 1 million, which also represents the actual distance. So how do you convert? We divide 60 by 1 million. Then we're getting 0.006 kilometers. But we can't measure that on the map. It must be either in millimeters or in centimeters. So in this case, I converted that one to millimeters. From big unit to smaller unit, we multiply. And remember, 1 kilometer equals to 1 million millimeters. So when we multiply that by this one, we get 60 millimeters. So this place, which is 60 kilometers in reality, when we measure it on the map, we must find 60 millimeters. Let's go to the third type of question you can be asking. You can also be asked to determine the scale of the map, given map distance and actual distance. The distance between 2 places on a map is 20 millimeters, while the actual distance is 300 kilometers, like the distance from East London to Port Elizabeth is around 300 kilometers. Now determine the scale of this map. So I have alluded in the first, when I introduced the lesson, that the number you put on the left of the ratio is the map measurement, and the one on the right is the actual measurement. So 20 millimeters is the map measurement, I put it on the left. Then 300 kilometers is the actual, I put it on the right. So now when you look at that, you will see that our units are different. But remember, a ratio should have same units. Hence, I must convert the kilometers to millimeters or centimeters. But since I have millimeters this side, I will use millimeters. Remember again, 1 kilometer equals to 1 million millimeters. Hence, I will say from big unit to smaller unit, 300 kilometers times 1 million, that gives me 300 million. Now, what do? I divide both sides by 20 millimeters. That gives me a scale of 1 to 1,500,000. So with the scale, these are basically the type of questions you can expect. Let me move on now to other parts. Now let's go on to the types of maps. Types of maps. I've tried to group them here. Remember, we have so many types of maps, but some can be grouped to be under one. We have street map. This shows the roads and landmarks within cities or towns. Mostly it shows the streets and towns, streets and roads in city locations, suburbs. Road maps, it depicts the major highways and routes between cities and towns. E.g., we have street map, we have route map. The types of roads, remember, we have national roads, which are depicted as N. For example, in the Eastern Cape, we can see from East London to Bloemfontein, we have N6. From Port Elizabeth to Bloemfontein, again, we have N10. We also have N2, which runs from KZN through the Eastern Cape to the Western Cape. We also have provincial roads, which are depicted as R, the R1, R2, R72, all those, they can be called provincial roads or regional roads. Then we have municipal roads or main roads. Those who are in big metros like Buffalo City and Nelson Mandela, you will see that there are a lot of roads which are represented as M1, M2, and the like. So we have maps which show that you are quite aware of how a street map looks. So let me try to check. Yes, we have, this is the street map here. We have the street map. We have the residential street map, the railway. These are the various maps I'm talking about. The street map is here. So yes, these are the maps. We also have what we call topographic map. Topographic map, the most common topographic map we have is the profile map, which we see mostly for the Comrades Marathon. We have a profile map. Let me try to see. Yes, I have a profile map there. You can see it. That's a profile map. What does it show? The profile map, it shows you the altitude, which is the height above sea level. It is also showing you the terrain or the slope of the area. It is also showing you the kilometers. This one we have here is showing us the profile map for the Comrades Marathon, which is run between Pietermaritzburg and Durban. If you are this side, the higher side is Pietermaritzburg, and the lower side is the Durban side. Remember, from inland to the ocean, you will be going downwards. This is the route map, and this one is a regional map. Let me go back to another type of map. We have a layout map. The layout map is mostly commonly used to illustrate arrangement of buildings or facilities, such as housing complex, shopping malls, or shopping centers in the rural areas. So basically, these are the 4 groups of maps. But you will find when you go to exams, they pick on specific maps, either the street map, the route map, or the general map, right? So I've shown you the types of maps here. Then let's move to what can be asked on the maps, right? You can be asked to give the general direction. What do we mean by general direction? We are giving the compass direction. The compass direction, we have 8 we use in mathematical literacy: north, south, west, and east. Then between the north and east, we have the northeast. Between the north and we have the northwest and the southeast and the southwest. When you get a map, make sure that the arrow of the map, there is always an arrow to indicate the north. That arrow, you must make sure it is looking in front of you. It must point in front of you. If it is pointing on the south, you rotate the map and ensure that the arrow is pointing in front. Then your side becomes the south, and your right becomes your east, and your left becomes your west. Right? Let's say you want to give general direction of A from B, and the north arrow is pointing this side. So it's the direction, general direction from A, of A from B. From B, that's where I go and put this cross. Then I put the north there, the west, the east is to right, and the south. So I connect A from B. So you can see it's connecting between S and W, which is southwest. So that tells me A from B is southwest. So when I'm on B and I'm looking at the side of A, it means I will look in the direction of southwest. So that's how we do the general direction. Thank you. Let's move on to the other question of giving direction. Describe direction. You can be asked to describe direction. Here you must write in point form. Don't write a paragraph, write in point form. You are now telling the person that to move from this point to this point, you are following this route. And how do you do that? You need to show where the person is turning, indicate that you are turning left. Where you are turning right, you say turn right, or you make a U-turn. Also, include the names of the roads or the major features. Like maybe when we are in town, major features can be schools, churches, traffic lights, traffic circle, library, the banks, these commonly known things like food outlets. So you'll be mentioning them as you are giving the person. Or maybe you're in a classroom. You want to describe how someone can move from one desk to the other. You need to give this instruction like stand up, turn left, move straight, count desks 1, 2, 3, 4, turn left, turn right, like that. But the emphasis I'm making is write it in point form. Number 2, you need to indicate when you are turning, which turn are you taking, left or right. Number 3, you need to include the names of the roads. You can also include the compass direction if you are maybe giving directions on the map. You can also include the major features like name of the road, traffic lights, important buildings. That is when you are giving directions. Thank you very much. Let's move on to the script chart map. I've just picked, there are many types of maps. I will not be able to look at all of them now. A script chart map is showing the major roads. So this one is from Springbok in the Western Cape, Springbok to Windhoek. So the numbers on the sides represent the distances between places on the main road in the middle. Then these ones which branches, the numbers are written either on above the road or below the road. This number you see written on top of the road is representing the name of the road. So I have picked a very simple one, Springbok to Windhoek. It's 892 kilometers. Now, Aaron traveled from Windhoek to Springbok at an average speed of 110 kilometers per hour and claimed that it took him 8 hours, 7 minutes. Verify his claim showing all calculations, 5 marks. You are coming to the issue of distance, speed, time. So to calculate time, in order to verify this, it means we must calculate time. Time is equal to distance over speed. Time is equal to distance over speed. So we're going to divide here. 892 divided by 110, we'll get 8,109090 hours. I'm not rounding. Now, I take the comma. The hours I have are 8, but I want to see how many minutes are represented by that decimal. So I will take the decimal alone and multiply it by 60 to change it to minutes. Then it gives me 6,545 minutes. So I round that to 7 minutes. So therefore, the claim is correct. It is 8 hours, 7 minutes. However, remember, you can use a calculator. If you take a calculator, you will see that there is that button which is fact on the Casio, and on the Sharp it is DMS. So after you divide here and you get 8,10900, you can just click that button written fact. It will automatically change it to hours and minutes. Remember, you can just click after you divide distance by the speed, you get 8,1090. Go and click the button written fact on your calculator, the Casio or DMS on the Sharp. It will split your time into hours and minutes. Remember, here we were calculating the time taken to travel from Springbok. This is where Springbok is. So you move up to Windhoek. This is where Windhoek is. So you look at the distances along here on the side. So it is 892. This is our distance to Windhoek, from Springbok to Windhoek. Is the one we use to calculate our time. Remember, again, I said when you are, for example, if I say I want the distance from Springbok to which place, to this one, Karasbeek. So I'll move up here and I get 268. Then I am here, 268, it means I am here. I turn to this place, there is 51 kilometers. So I'll say 268 plus 51. That gives me the distance between these two places. Remember, I said these on the sides, they represent the places here. So from Springbok to this Fourth Reef, it's 129. Then Springbok to this Casement Swoop, it's 427. To Mariendal, it's 644, up to Windhoek. So that's how we read the script map, right? Let's move on to the other aspect. Let's look at the floor plan and just look at few questions. Remember, we said the floor plan shows the top view of the inside of the house. It helps us to show how the rooms are arranged. So with the floor plan, it also has the compass directions. Look at these compass directions here. We have compass directions there. Look at these are compass directions there, which shows us which room is on the north and the south, right? The scale is 1:100, and the key there is showing us the door. These are the doors. So when we have this plan, remember it's two-dimensional. It has a length and the width. Now let's quickly go on the questions which can be asked there. Determine how many windows and doors can be seen. Determine how windows and doors can be seen on this floor plan. They can be seen using these symbols. This is the symbol for the door, and the window is being put by a line like that, right? In which general direction does the living room window face? Let's look for the living room. This is the living room. Where is this window facing? Remember, this is the north, this is the south, and this is the east, and this is the west. So this window is facing the north. It's in the north side. The window is facing the north, but since you see our north is in the corner to be precise, we can say it's northeast. You are being precise there. Learners, look here. The question says, determine in which general direction does the living room window face? So as I've said, come here again. You make a small cross here. You make a small cross on the window there, following how this one looks like. So this one looks like that. So this is where the north is. This is where the east is. This is where the west is. This is where the south is. So you can see our window is facing this side. So you can precisely say it is facing northeast using this where our northern compass is following. I mean, the north direction is indicating. So, but mostly examiners are not very strict here. If you have picked that it's north, but precisely you can see that it's in the northeast direction. Thank you. Name the type of plan that will show the side views of the house. I have already discussed it in the beginning of the class that the elevation plan shows the side views of the house. Explain the meaning of the scale. We said 1 unit on the plan here represents 100 units on the actual house, because the plan is representing the house. So I will say 1 unit on the floor plan represents 100 units on the actual house or on the actual building. Give the general direction of bedroom 1 from the machine room. Right, let me erase this one first. Right? General direction of bedroom 1 from machine. This is where bedroom 1 is. This is where we have bedroom 1 and the machine room is here. So we are changing here from, because it says from the machine. So I come here, I follow that one, how it is put. Then I put mine also. I put mine like that, where it says from. So we can see that this is northwest. It is between the north and the west. So the bedroom 1 is in the northwest direction from the machine room. So you can see basically you can be asking the same questions on the plan and same questions on the map. So you need to master the same things. To conclude this class, this lesson, we have mentioned the types of scales are number scale, bar scale. We have mentioned we have defined the plan, map. Scale means we said scale is used to reduce the size of an object to make it fit on the paper, and the map represents the Earth's surface in 2-dimensional. Then the plan, the floor plan, shows the top view of the house or the inside of the house, and the elevation plan shows the side view of the house. We have come to the end of our lesson. You can leave your questions on the comments. Don't forget to leave the name of your school. We give shout outs. Please share, recommend, and subscribe to our YouTube channel. Thank you for watching. See you on our next lesson.